Hello, my name is Dr. Heather Brown. I am a professor here at Middle Tennessee State University in the Department of Concrete Industry Management, which probably doesn't sound like a major that you're very familiar with, but I'd like to make a connection for you. I am working with faculty all across campus in a multidisciplinary role, utilizing the basic principles of biology, chemistry, and environmental science to teach applications of concrete. So let's think about concrete for a little bit. Where do you see concrete? Concrete is the second most used material, second to water. So you use water, and second to that, you use concrete. Well, how do we use that? We use that in what I like to call the built environment. So when you think about what's around you and the buildings that are in place, many of those buildings were built post-World War II. So now we're coming across 60 to 70 years of a built environment that's aging. And we need to understand the impacts of how it's going to affect the future generations. As those buildings are being aged and deteriorating, we need to build it back even better. So I like to connect concrete to geology, biology, and chemistry in ways that make the materials better and in ways that affect the environment in a positive way. One thing that I look at quite often is storm events. Storm events is something that plagues not only the built environment from a flooding aspect, but also just the quality of water coming off of our construction sites. As we build and grow into places that typically didn't have construction before, we find that the quality of the water is really affecting our local lakes and streams. It's affecting where we can swim. It's affecting our water as we come into our homes. So it affects you just as a normal citizen. I look at ways to try to maximize that storm event into the built environment. Can I use that water in a different way to be able to use it throughout the building structure? Like, is it gray water? Can I flush my toilets with it? Can I wash my hands with it? Because I'm actually utilizing it within that built environment. So I'm interested in getting students excited about materials that can take us into the next generation of green construction. And green's kind of a word we throw around a lot in concrete. It's really building back with materials that make sense for our future. And if we can understand instrumentation on campus that can be utilized in testing water for surface conditions, then you really are getting a first-hand look as what kind of construction is going to happen in the future. So you'll really understand the effects. So I'd like to utilize these equipment labs that we have on campus that aren't all housed in concrete. So we're sort of the application of these core sciences. So if you're interested in science, you can apply it to construction and then have a job skill that allows you to understand construction and basically building the environment in a better way. So I'm excited about having students come to my department, work with me throughout a summer term, go out to basically sites all around Middle Tennessee. We have sites just down the road that allow you to see that water quality in effect working with new materials, and then what happens when it's not working. Where are we looking at sites that are really causing some problems for our local lakes and streams? Let's do some comparisons. Let's take some water samples. Let's get in here and look at EPA standards and really understand the codes behind it, building codes and also technical standards. So I'm going to introduce you to a lot. It's going to be a lot of information to take in, but it really is applied and it really gets people excited about what's coming ahead of us. And so I'd love to take you on a journey through water quality in Middle Tennessee and really understand instrumentation.